Hello, hello. This is Postgres FM. My name is Nik, Postgres AI, and as usual, with me, Michael, PG Mustard. Hi, Michael.
Hi, Nick.
So,
How you
topic.
doing?
I'm doing great. How are you?
I'm good, thank you. What's the topic?
Yeah. What's the topic? The topic I chose, and everyone already saw it on cover you created, right? So, the topic is 5 or so, maybe 6 things you should check when you start new schema, or you already have some schema and your project is growing, and you want to be better prepared for bigger scale and performance-wise. So what, especially if you use AI to design and improve your schema and your project is growing again, right? So what should you look at to check your schema health?
Makes sense. Just on the topic in general, I do think there are some things that are better suited to asking for help from AI and not. Do you think like schema design is one of them, or actually is it one of those ones that maybe we should still do it a little bit more ourselves at the moment?
Well, as you know, I'm very, very, very intensive user of AI.
Yeah.
Honestly, like I do everything through AI right now. And I'm 100% schema design is a topic where AI can help a lot. But it also matters which questions you ask. If you just say, I want this and don't pay attention, you will have low quality schema in many cases still. That's why I said, let's have this episode, because it might be quite basic for many advanced users of Postgres. But this checklist we are going to present today, it can be good thing to keep in mind always when you design schema, just to ask right questions and revisit. Also, I'm not sure how exactly you use AI. I use it always like I work with people, developers.
Yeah.
When you just ask something and think those engineers, humans or AI, will solve all your problems and make all the decisions, you're offloading full responsibility to their shoulders, so then you have big negative surprises always, right? So it's better to keep requests as detailed as possible when you work with AI, and also make some iterations to review and improve. And when making iterations, like first, like I want some schema, like, I don't know, like LinkedIn social media schema or something, right? It will give you immediately something, but then you want some details to be checked. And this is exactly when this checklist can be very helpful, so you can revisit and think and imagine when you will have gigabytes and terabytes of data, what will happen. So to avoid painful refactoring in the future and outages maybe or performance degradation, the price you can pay in the beginning is much lower than the price you pay later, right? So I never work with AI in one shot. I always make iterations to improve in any question and to revisit and sometimes combine multiple LLMs, right? So this is exactly when you can use this list of questions. So the first topic is the data type of primary key.
Yeah,
right?
And I feel like the answer to this has changed. My opinion on what the best default for this has changed actually in the last few years, just off the back of learning more about timestamp ordered UUIDs. Right, this used to be an age-old debate, right? UUID versus integer or big integer, really. And most of the kind of blog posts I would see are like trying to just encourage people to use big int over int. Yeah. But now that we have first-class support for time-ordered UUIDs, I don't see many reasons not to go with that. What do you think?
Well, the size 8 is 8 bytes.
Is double? Yeah.
Yeah, UID is a 16 bytes, so it's quite a big price to pay. In each row, you need to have 8 more bytes.
It's not.
In many cases,
though,
it's
right?
fine. Well, indexes will be also bigger. So
index is double, yeah.
It might make sense if volumes are huge. But anyway, to keep things simple, rule to remember, red flags. If you are prepared for really large volumes of data, it must not be integer 4.
Yeah.
It should be integer 8. And if in terms of UUID path, Data type is always UUID for both version 4 and version 7, but you can check default how it's generated. And in modern Postgres, there is a function, I think in 18, only in the latest version.
I think maybe. So. It didn't quite make 17, did it?
So if you're on Postgres 18, so it's better to use UUID version 7, but also remembering trade-offs, because there is timestamp there and the values will be ordered like with integer or big integer. So there is a nuance here. But performance-wise, it's much better than UUID version 4. There are many articles about it, and you just need to check. Okay, are we going to go with integer? Then it's int 8 or big int, right? Are we going to go with UID? Then default generation default should be version 7 for Postgres 18. For older version, it's also not an excuse to stick with version 4. You can write your own function. And you ask AI to write your own function.
Or generate them outside of the database.
I slightly prefer this option less because if you have multiple application nodes, who knows what will happen with their clocks, and since UID version 7 includes timestamp inside it, order might be not. I don't know. Like I prefer to leave it on database shoulders, to have like on the primary single source of truth. On the other side, UID by design is generated. It serves a purpose to work on multiple, like on distributed systems, right? So maybe it's not a big deal. Generate on client side.
All I mean is if you're on an old Postgres and you saves you creating your own function or whatever.
Yeah. Postgres waited a couple of years to bring UUID version 7 officially. Although again, you can create even SQL function, even not PGSQL function, simple SQL function. And if you ask your AI to search for example, probably it will find my page how to do it, or other people pages. But in other libraries from Google, for Node.js library, everything, they have it for a couple of years already, so for longer. They implemented before standard was finalized.
Yeah, so huge red flags to look out for are if it's using the integer data type, which is same as int4, or serial. I think AI sometimes uses, it will define it as serial. So if you just see that word without big serial, you might hit that limit at 2 billion or whatever I can't remember the exact upper limit.
Yeah, and avoid UID version 4 if you want good performance on large volumes of data. Yeah, that's it actually. Let's keep it simple because we could discuss more advanced situations.
I think we should do a whole episode someday on migrations, for people to getting close to that 2 billion number. That would be a good topic.
I can share. I had a lot of experience with different approaches. Yeah,
let's do that.
Good. So, how to redefine primary key? I can actually have an article about it. How to
cool. Let's
covering multiple paths, so we could talk about this. Number 2 is constraints. Topic is constraints. It's
other constraints. Yeah,
other beyond primary key.
Yeah.
So I would just ask, first thing, are we using constraints well, to myself or AI and so on? And because Postgres has 6 types of constraints and it's quite rich tooling, and it's much more convenient to have them earlier, not because adding them later is a big pain. Right now we have quite good support of two-step constraint definitions. First, I think in Postgres 19 it will be possible also with not null constraints, which is interesting. But anyway, check constraints, foreign keys, unique constraints, it's possible to create first in almost finished state and then finalize it to avoid the long-lasting locks. But this is not the reason why I prefer to think about it in the very beginning. The main reason is the quality of data. This is why constraints exist in the first place, right? So if you introduce constraints early in your project, data quality is good. Introducing them later probably
and database side as well. I mean, just
I don't trust constraints outside. I with age I became less radical. My points of view became less radical with it. So I just observe without fighting, with backend engineers who try to implement constraints on application side. I just have a note, like they are not reliable because who knows which other layers of types of application, especially these days with AI. It's so easy to add something else implemented in different framework or even language. It's super easy right now. And you will need to re-implement those constraints, or you will just forget and miss them, and data quality will suffer, right?
Yeah. So specifically, something I think I'd like to see more of, or at least I see a lot of people not doing, is columns that you're not expecting to put any null values in, or you don't want to have any null values in, actually explicitly making them not null. Like, if you don't specify, then columns are nullable. And I think most people, or at least most AIs I see, are creating, like by default, they don't put not null on every column.
Yeah, there's an opinion that not null should be default. Anyway, it's hard to have a default, but inside your project you can say, okay, unless it's explicitly specified, let's make columns not null.
Exactly. Yeah.
And avoid troubles with null we talked about in a special episode about nulls, right?
Yeah, well, and I guess in this specific case, there is also, well, with some constraints, mostly we care about this, we're doing it for quality reasons, but there is like a tiny amount of performance optimization that comes out of them. I guess a bit more for unique constraints. Like if the database knows for sure this is going to be, this is unique, it can do some optimizations. So yeah, anyway, but yeah, good point I like that about not nulls.
Unique is interesting stuff. And also, of course, I don't think foreign keys are underused in Postgres ecosystem. Days when everyone suggested that foreign keys are super bad. For me, it's 20 years ago. I remember these topics. Let's avoid foreign keys completely. Although we know that foreign keys can bite badly. We had episode with Metronome company about issues, basically, which with multi-exec related issues, which can be caused when you use foreign keys a lot. But anyway, like I still think foreign keys is a good thing to have, like data quality. But I think what is usually underused is check constraints. They are great. They could be used much more often. And for example, a classic example, when I say, like, when I see in schema enum data type, I think, okay, later if we want to change this list of possible values, how will our migration?
Especially removing any. It's a pain.
So check constraints are slightly like more flexible in this. Like well, also removing is a topic, right? But check constraint you can introduce in two stage. Again, you can drop the old one, and you can first create a new one in not valid state, and then validate it in separate transaction. But I just see it like quite useful, quite convenient tool for me, and you see it in schema right away. Like this column should be, like, for example, in this range, or it should be this list or something. So I wish it was used more often.
Yeah. What do you see going back to foreign keys quickly? Do you see a lot of the LLMs doing a lot of things on update cascade or on delete set null or things like that? Do you see any cascade stuff popping in there by default, or not when it should be, or when you think it should be?
It's a good question. I actually don't remember having issues with this question. I know deferred constraints are might be an issue. I remember a case when PG repack, it was a company called Miro, maybe you know it, right? They had issues with PG repack and deferred constraints. There is an old article from them about this. But I don't remember particular issues here. And I think this leads us actually to the question for our particular projects, what's better. And if I had any doubts with AI, I would just make some experiments. Based on the product we are developing, I would say, okay, for example, in 1 year, how many of entities in which entity table we expect? All other tables, let's fill it with fake data, right? Run vacuum analyze to have good state, and then just explore plans with PG Mustard, for example, right? Let's think what kind of workload we might have according to user stories in our specification of the product and so on, and then collect plans and see, right? And then include also modifying queries and collect those plans and think how it will work. It's so easy these days to make these experiments before we finalize all the decisions, and then you will see it in action, and it's great. So collect all the plans, find like weak spots where we have suboptimal plans, and how we can deal with this. If, for example, we have an entity and another and one too many, and it's so many, right? And then we want delete to be supported in UI, where people, as we know, expect 200 milliseconds and less than 1 second, let's say, right? And when this delete of one row triggers propagating according to foreign key triggers deletion of 1 million rows, it cannot meet our requirements, right? Now we need to think about asynchronous deletion, maybe if using some event queue system or something, right?
Yeah.
And this will pop up if you prepare a good experiment here, right? Without experiment, it's hard to say. You need to answer questions: how big are the tables, and how like this relationship between tables on foreign keys will be in the worst case, for example. Can user create like million of entities, and then we need to delete this user, for example? This is a great question, and with AI you can iterate so fast these days. So great. Collect plans and then think and decide. Yeah. Okay. It's a good question, but I don't see it as a simple question.
No. It was more, I just asked in case you'd seen there was a chance that LLMs were throwing it in on every foreign key, and that was maybe a bad default, but it sounds like they're not.
I may be a wrong person to ask about this, because I design sometimes these days. I have a few applications designed created from scratch with AI, but I mostly deal with things which other people already created, and I just see how AI can help. So I'm not sure will this like propagation of deletion, for example, will be like supported in how exactly it will be implemented. But it's definitely worth thinking in the context of latencies and what should be offloaded and what tools will be using to offloading this to background jobs, for example. Yeah. Anyway, it's just a thing that you need to instead of looking at code, I would think looking at dynamic results, experiments.
Yeah. And I'm thinking, like, if we're talking specifically about schema design when you expect to hit scale, I might default to not using on X cascade just by default because at scale it can become problematic. So that would probably be, if you had to come up with a best practice for if you're designing at scale, maybe lean in that direction.
That's interesting because this was my position for a long time, but it's not about AI building or something. This was my position. Let's like it's dangerous because who knows how many rows we will need to delete. It's unbounded delete, right? Unlimited delete. This is how it feels. Let's design without it. But then I see in my consulting practice, I see cases where really large projects have it, and it's just not one project. Many projects I see. And they keep it and somehow live with it. They at some point implement non-cascaded, like asynchronous deletion, but by default they still rely on cascaded deletes somehow, and they are fine. This is interesting. So reality shows it's not that bad. But I agree with your way of thinking, and this is my default way of thinking as well. This is like Postgres can survive very terrible things these days much better than like 20 years ago.
Yeah.
Including
and I know,
of
the only time I see that being a like horrendous issue, even in small to medium-sized projects, is if people haven't indexed the
second part of foreign key.
Exactly, the referencing column.
There are two ends of foreign key. One is always indexed because it's primary key. The other one, it's your job to index it, right? Not to forget. Yeah. We have in our all checkup actually, we have a special report just for this case. Yeah.
Perfect.
Good, but it's all good questions. But I feel we can spend a lot in the constraints area. I think we had constraints episodes.
We did have an episode. Yeah. Let's link that up and move on.
Yeah, let's move on. Some entertaining topic, column Tetris, which is sometimes it might bring some quite interesting and good saving. In many cases it won't, but I just see people enjoy this topic, and I decided to include it. So the idea is when you design new schema, the price to pay to reorder columns is very low. You can reorder it easy. And the problem is that Postgres physically, the column order matters. And due to padding alignment, if integer 2, for example, is followed by integer 8, you will see a gap 6 bytes of zeros in every row. And this is bad, right? It's like a waste of storage and also memory, which is not only disk, it will pollute with those zeros, it will pollute memory. And sometimes you can be so unlucky. I saw cases like 30% of each row is like zeros. And Postgres doesn't have automatic reordering of columns. It could actually, but it doesn't have it.
So the order you define it in, let's say you do create table, the order you put those columns in, that's the order they end up on disk. And every new column you add goes at the end.
Yeah.
That makes sense, right? But even if it could be slotted in, let's say you add a new Boolean type, and it could, I don't actually know if that would work, but it always goes on the end.
Boolean is 1 byte.
Yeah,
but in Boolean, 7 bits are wasted already. If you zoom in, like under microscope,
unless you put Boolean next to each other, right?
No. Boolean
really?
is 1 bit.
Bit. Yeah, good point. Sorry.
But it's stored as a 1 byte. 7 bits already wasted. But if you have Boolean and then timestamp, for example, if for example, first column, as we all agree, should be ID, primary key. I'm joking. It's not always, but it's very popular. ID is the first column. Integer 8 occupies whole 8-byte word. And then we have Boolean and then timestamp. Not only you wasted 7 bits inside Boolean, it's already by design. Like Postgres doesn't have like less than 1 byte. But then you waste 7 bytes. So 7 bits first and 7 bytes because of this alignment padding. And your Boolean, which is like by sense it's only 1 bit, suddenly occupies 8 bytes. It's a huge waste of resources, right?
Yeah.
But the bigger picture here is that people usually realize that waste is significant only when it's a huge table, like 100 million rows, right? And then, so many spaces wasted because we didn't play this column Tetris initially. But this is like a chicken or egg problem, like maybe inverted. Anyway, so you realize it later, but you could do it earlier, but you didn't think about it, because when you have only 1,000 rows, for example, it costs you nothing. But with AI, it's so easy. You just say, let's play column Tetris in Postgres. AI should know it. I haven't tried, but I'm pretty sure it should know it, because there are many articles about it.
Oh, and we did an episode.
Yeah, starting from Stack Overflow, where this topic was very well described. So AI should know it, this topic. When you create new table, you think many rows will be stored. Just let's apply column Tetris to this. Boom. It will reorder columns. Never tried again.
Yeah. What do you think? Like, I feel like there's I don't know if I'd still want to do it myself, just because I feel like there's also a natural order for columns. So I would want to put all the 8-byte ones together and 16-byte ones, and make sure they're all with similar, and then all of the exactly.
Similar.
But equally, like, imagine if it's like a users table, and I could put certain information about that user that makes sense to go together, and then information about something like maybe like all the IDs, that maybe the foreign keys, like their team ID or their organization, all of those kind of like referencing columns, put those together. So I know the order doesn't matter. Like, I know you could just specify column order, but you know, when you do select star, or you just...
This is what I was trying to say, like, are you trying to tell me that you're using select star?
Yeah.
And here we go. So I'm joking, actually. I'm using select star all the time.
Yeah.
But all the time I see articles how bad it is to use select star. Right? It's
And
convenient, I know, yeah, but also if you manually work, it's inconvenient to have order, and select star doesn't work well. But application shouldn't use select star.
you're right. And even
Yeah.
I'm even thinking about examples like the system views in Postgres, like you do select star from pgstat statements or something. Like, but that's not even the table, right? That's the view, and then they can define the order. So it doesn't actually matter.
It's interesting topic. I played column Tetris a few times heavily, and then it was really inconvenient. Oh, like this is ugly table. It looks ugly. Like this order it's ugly. But at the same time, it's your problem that because you used select star, which is considered like not a good practice. It's
Yeah.
practice for exploring and so on. Okay, explore with AI. Ask to provide better order or something. I don't know. But anyway, if we focused on performance, again, I saw cases where it was significant waste.
One of the first articles I saw, and it was by Braintree, and I think they reported an average of about 10% on some of their largest tables.
It depends.
So obviously, it completely depends, but that was quite surprising to me. I know you mentioned like an extreme case where you saw 30%, but I was quite surprised that in an actual production case, it was as high as 10%. And when you're talking about hundreds of gigabytes or terabytes, that's actually a decent amount.
Yeah, exactly. The problem also, of course, in existing projects which were developed during many years, usually it's not so simple because the schema is evolving during many years, and you cannot insert your new column in the middle. It's always, as you said, at the end. So sometimes we do need to, for example, to change the order using some redesign thing. By the way, have you heard that Postgres 19 will have repack and also repack concurrently, which is basically vacuum concurrently. We had an episode with author of PG's quiz.
Is a vacuum full concurrently?
Exactly, not vacuum vacuum. But the decision was made to name it repack concurrently.
I think that's sensible, getting away from people thinking it's vacuum related, yeah.
I haven't looked into details, but I might, naturally this is the point where you could reorder columns because it's based on logical replication.
Yeah. I suspect if they do that, it will be a different keyword again.
Who knows? Again, I haven't looked into details. There are long discussions on PGSQL hackers mailing list. It feels naturally because it's based on logical replication. This is where you can reorder columns and play Tetris for existing large tables. Right?
Yeah.
I hope it will be implemented at some point. Maybe it's already partially implemented or something. I don't know. You basically, you before you start filling the new table, you can reorder it because it's logical, right? It should be possible. Anyway, this is column Tetris, entertaining topic. Let's move on to more serious topic called indexes, index chaos.
Yeah.
If you just use AI and if you don't spend enough time for things, as I said, like experimenting with real data benchmarks, you might end up with under-indexed situation or over-indexed situation. And usually people are scared to have under-indexed. In my practice, I see over-indexed very often, sometimes to extreme.
I guess for new projects, I would be surprised to see them over-indexed. But
it's possible. It's possible still.
Is that like as a result of AI or something?
Well,
else?
The problem here is that again, everything depends on your prompts. Depends on angles. If you say we will need to order by arbitrary column, right? Remember our episode with CTO of Gadget, Harry, right?
Yeah.
So any column we can reorder. Naturally, AI might decide to put index on every column, right? But is it really what we want?
But that's what Gadget decided to do as well, right?
Right, but with understanding consequences, right? But in reality, will it be used if 1 year later you see that 90% of those indexes are unused? And Gadget has special case. They have many applications to support. If you design your own only one application, this is where I would just stop and think with AI again, with some experiments. I would ask questions like this. All depends on workload, right? Which queries we will have, right? And I will just think which queries we will really need and which we won't need, and then choose a proper minimal set of indexes.
Yeah, I like that. I think there's also like some rules of thumb we can give people in terms of like how many is that where it starts to get dangerous for other reasons. But the kind of one place where it's not even and it depends is overlapping. And I see more and more where people are adding indexes based on AI suggestions. They're adding indexes they've effectively already got, or they're adding ones that overlap with indexes they've already got, and therefore only one of them is needed at this. And by the way, it won't always show up in your stats. It won't always show up as an unused index because it is still using the smaller index.
It will show up in Postgres AI stats because it's called, in our case, redundant index in Postgres AI monitoring systems and checkup. I never heard the term overlapping. I see people talk about duplicate indexes, which is like trivial case, exact same definition, right?
Yeah.
But we call it redundant indexes. It's not easy topic as one might think, but we solved it in many over years. We have quite good detection approach how to reliably detect redundant indexes, and as you say, this is true. In many cases, all of those indexes are used, and it's quite like. There is a big fear. I'm going to drop this. It's used. Should I drop it? Yeah, but the reports we have quite reliable, and of course, I wish we had very native standard algorithm to disable indexes for some time, without involving hyper-PG and hypothetical indexes, which
this came
currently
up.
Supports it.
Our last episode was on what's missing in Postgres, and I think we got a nice comment. I've forgotten who from, but saying one of their features that would be make this index invisible.
Hide index from the planner. There are extensions for it. Hyper-PG supports it, but we want some mechanism beyond index setting, and index is valid to false. We want this. Yeah, I agree. And this is a good thing to probably work on for those who want to start hacking Postgres. It's a good thing to officially implement something. Anyway, questions to ask should start from understanding workload. So we cannot think about indexes without understanding workload. So first we need to generate some fake data and then start thinking about usage patterns. And without AI, it's really hard work. It's a lot of time. With the AI, it becomes easier. If you have user stories defined already, you understand what kind of patterns we will have, and you can start imagining. You probably will. It will not be 100% accurate, but it will be good enough, much better than without it or with manual work. So you can iterate here and see, and then with queries in hand and some lab already developed, I see it should take 1 or 2 hours for medium-sized project. I mean, in terms of complexity. And then you can start iterating, collecting plans, and think which indexes you can have, playing.
But also, whilst this might be the most important in terms of performance that we've talked about so far, it's also the easiest to change later, right? We can set up a certain set of indexes and later decide we want a slightly different set of indexes, and that's not super painful in most cases, especially if there's no partitioning involved. So that for me feels like, it's important, it's really important, but if we don't get it right on day one, it's much, much easier to fix than the primary key being the wrong data type or not having the right constraints in place, that kind of thing. Or even the column order,
So the point is, you should build wind tunnel for your project, right? Test lab, database lab. And then you should put this workload wind and see how your profile of your database behaves under this wind.
Yeah, a lot of people do that with production. They just see which of their slow queries and
helps us with AI. It's easier to have massive experiments before you finalize all the decisions. So my point is, do it. And then questions to ask: are there any indexes we don't need in terms of are they redundant or unused, or what indexes are missing because we have bad plans? And this again, pgmaster will visualize it and so on. And you have API already, right?
Yeah. It's quite nice.
You can connect your AI to pgmaster, for example, and ask to use pgmaster to explain what's happening and find bad problems. and missing indexes with this lab environment. Great.
Yeah. Going just like to the extreme. How many indexes on a table would you automatically just think, oh wow, that's like a lot? Maybe it's justified, but I'm already thinking that's too many.
These rule of thumbs are quite weak in my opinion, but we had them anyway. Like for example, if volume of indexes exceeds volume of data, it's already some bell is ringing, right?
I like that. Yeah.
That one. Or before Postgres 18 with this nasty lightweight lock manager problem means I don't want more than 15 indexes per table.
Yeah.
Right?
Because of the 16 relation limit for the fast.
It's so simple.
Locking. Yeah.
Primary key lookup, which quite likely will be will have quite high QPS, will suffer, right, because of locking. So there are a couple of kind of these rules, right? But they are not strict, and again, I consider them weak. But maybe. Yeah.
But I think it's still helpful, right? If you've got a schema designed by AI and it's got 20 indexes on one table, maybe consider, is that smart?
Yeah. But it happens. Cool. Index data exceeding heap data, it happens.
Especially with some, especially like if you're doing gin indexes.
Oh, yes.
If it's just B trees,
Yeah. Okay, great. So the final topic, we couldn't decide on which one to choose. We had two ideas. One is RLS and another is partitioning. Let's touch both maybe.
Yeah, I think so. So from an AI perspective, like when you're asking it for a new schema, do you see partitioning come up? Does it over partition?
It won't come up unless you start saying I'm going to have a lot of data here, and I want good performance. I want billions of rows stored in this table. It should be maintainable. It will naturally come to the idea of having partitioning, right? Partitioning will be interesting to join with UID version 7 or 8. Doesn't matter. It's possible. Again, I have a recipe for this in my set of how-tos, and it can be. Also, the question, like partitioning, you cannot develop without understanding workload again. It's similar to indexes, like it will be something, but how it will behave, who knows? So maybe you will end up, your queries will need to scan all partitions, which is terrible in most cases. And then planar behavior. Anyway, the questions to ask, like you set requirements. I want a lot of rows, and I want maintainability of this. Help me. What
like
problems?
Deleting old data? Are you thinking like archiving?
No, creating indexes, for example, or reindexing.
Okay, yeah, sure.
Right?
Vacuum.
Load. Yeah. These are problems biting us much more often and badly than just, I don't know, like, we talked about this a lot as well, right?
I know.
Yeah. Direct performance benefits from partitioning are good, but also the problem, like when creation of index or full vacuum, not full, but regular full table vacuum, it will take hours or half a day. It's already so painful, especially if it's to prevent transaction wraparound, or if it's again indexing means that X-min horizon. Like anyway, let's not go too deep. The question to ask: will we survive n number of rows because we expect a lot of data? Right. I want.
And just out of interest, is it pretty much always doing range partitioning based on timestamp type? Is that pretty?
Again, I'm the wrong person to ask.
Okay, yeah, fair enough.
In many cases, I just still use timescale DB if it's time based.
Yeah. Makes sense.
And I'm happy because there is compression there. It's great. But I also saw cases when it was decided, it was not AI, but it decided like list partitioning and full control over partitions, a special table created. It was also working well and served needs. But on surface, you should think about workload and then push your AI or something to think about how it will behave if you have that much data. Partitioning is inevitable there. And then experiments again. Even experiment with billion rows, it won't take a lot. Just allocate machine and do it. It's like just so easy, right? Half an hour of wait to generate it, or more. Like even if it's 1 hour, why? I don't understand why people don't do it all the time. They come to us with questions, which I'm grateful, thank you, with money and so on. But it's so easy just to experiment more often these days.
Yeah, even leave it running overnight.
Yeah, exactly.
I'm
with
still
with some plan.
Yeah, I'm still on the fence with. I love partitioning for all the reasons you mentioned, but I think so many projects won't ever need it that I understand not doing it by default with a new project unless it's like a new feature for an existing system that you know is going to get heavy amounts of data really quickly. Just there are so many trade-offs like that. It's still a little bit like
Which trade-offs?
So, for example, indexes, being able to create indexes concurrently, drop indexes concurrently.
You can concurrently create index on each partition, and then when it exists on each partition, you can create these things can be automated. And of course, I like to be everything much more better automated. There is a big potential here, but also every Postgres version gets a lot of improvements in this area. Last maybe 10 years already. So it's not on like frozen.
Yeah,
Evolution
but also
is not frozen.
Just being extra careful that every high frequency query you have contains the partition key and is getting pruned at planning time.
Yeah.
Like there are a few gotchas that
there are. I have a series of articles about this, and I went quite deep there, and it was crazy. Yeah. Also,
but that's my hesitations. That's why I'm hesitant.
For example, working with timescale DB, sometimes like often we just abandon the idea of having foreign key because it's not supported. If you do partitioning yourself, you will deal with if you have large tables, adding foreign key between them. Or if partitioning is involved, it's an art, I would say. And GitLab master that they have migration helpers RB. This is a great source of experience of many people involved, and I can't stop recommending how great it is because it's open source. Right? So it's a great place to look at, and also they have great documentation about it. But anyway, like it's a thing to decide. If you don't expect billions of rows, don't do it. Of course.
Yeah.
At the same time, we have also very sad cases when people come to us for consulting. We identify problems. We say partitioning is needed. Right. Sometimes we go and spend a lot of effort because project is huge or there are many of databases to take care of, and then finally it's implemented great. There are many hidden dangers to explore. Mid-Journey, for example, they came to us, we helped, forgot about lightweight local. Not forgot, we didn't know about that time, and they hit it. Lightweight local manager problem was hit badly, and there are articles about it. But then some projects just say, okay, they evaluate how much effort it is to deal with partitioning when tables are huge, and start talking, okay, maybe we should migrate to MongoDB.
or even sharding, right? Like instead, I think when we talked to Notion, Arca, he mentioned that because they keep their shards relatively small, they've opted to not partition at all.
Yeah, the need partitioning diminishes. I agree with this, but not vanishes completely.
What maybe?
Not maybe.
You mentioned it depends how small you keep your shards, right?
Yeah.
Like Sugu, for example, Multigress, he talked about having lots of smaller databases being much easier.
Yeah, maybe you're right. Okay.
What about RLS? You mentioned you wanted to touch on that.
Yeah, finally RLS. If you, for example, I just noticed it's not like Supabase is very heavily like promoting RLS. They have a lot of articles, including how to avoid problems. But if you just use AI, I noticed it often adds RLS.
Oh, really?
Yeah, just this is how it works. I just noticed I have had a couple of cases where suddenly it brought like we are going to use RLS. It's multi-tenancy here. Let's do it. Okay, let's do it, but let's also pause and think about performance and avoid problems like current setting inside a loop, and you select count of million rows suddenly becomes super slow. So the question to ask AI, like again, benchmark is ideal here, right? Like with RLS, without RLS, what is overhead of having RLS in our particular case? Let's benchmark it. And if you see it's not okay, then let's optimize because there are tricks how to optimize it. So I would just, if I notice AI-generated schema with RLS, I would ask question like, what will be performance impact? let's benchmark it, and if it's bad, let's optimize. That's it. Yeah. Great. That's
Nice
it,
one.
actually.
I think that's a useful checklist, actually.
5 or 6 things to ask your AI when you design schema.
Yeah, or your colleague, even.
Yeah,
Human
also,
or
or your own
robot.
schema,
Yeah.
which you have already 10 years. Why not?
Yeah, exactly. Or even a new table. If you're doing a new feature, it still makes sense. So all of these make sense, right?
I agree. Cool. Thank you
Nice
for
one.
listening. Yeah. See you soon again.
Catch you soon.
Bye bye.